Anthropologists have long been fascinated by human variation. One particularly interesting type of variation is hair pigmentation. Research on hair pigmentation has mainly relied on descriptions of hair color as blonde, brown, black, or red. But are we losing information by relying solely on perceived hair color? My research aims to improve our understanding of how our subjective perception of hair color is related to objective measures of pigmentation. What gives human hair and skin its color, or pigmentation, is melanin. There are two types of melanin: eumelanin, a brown-black pigment, and pheomelanin, a yellow-reddish pigment. To do this research, we start by breaking down hairs through certain chemical processes. I use these chemical results to understand how the amounts and ratios of eumelanin and pheomelanin are related to different hair color categories that we perceive. Results from these analyses show us a pattern that we expect. The lightest hairs have the least melanin, the darkest hairs have the most melanin, and red hairs specifically have a high amount of the red variant of melanin, pheomelanin. But differences between hair colors are unclear. Not only are differences between categories blurred, but there is a huge amount of variation within categories. For example, within the category of red hair, there appears to be a lot of variation in both eumelanin and pheomelanin content, which relates to categories of red hair like strawberry blonde, auburn, and bright red. And within the category of black hair, we find differences in eumelanin content between populations. This means that we can measure variation that we cannot perceive. This research has the potential to change the way we think about hair pigmentation by showing that hair colors don't fit into neat categories. Using the quantitative results from these chemical methods will allow us to test evolutionary hypotheses and gain a better understanding of how humans evolved the impressive diversity in pigmentation that we see today.